Morning, everyone, and welcome to the third or the latest installment of our 2014 MagTug webinar series. Before we jump into the webinar, a couple quick things about who MagTug is. We are the Mid-Atlantic Geospatial Transportation Users Group, which we've been around for about 10 years, and one of our goals is to help transportation professionals stay on top of the advances in geospatial technology. Now we assemble these webinars knowing that it's difficult for all of you guys to get to an all-day event, so we kind of put in place a regular webinar series here that can help showcase different technologies and illustrate some best practices for how the technology can really be of value to the transportation industry. Before we get into the presentation, a couple things. February we'll have another webinar on GIS application that helps with snow removal. In April, we will have a webinar that talks about correcting and influence commercial digital road mapping with our own data. And in June, we'll be showcasing advances in GIS education for transportation professionals. Also, as we mentioned on our last webinar, we hope that you're able to join us at the symposium in Villanova, where we're going to further dive into open source and open data, and that is actually on March 5th of 2015, so mark your calendars for that. If you have any interest in participating, presenting, talking about an open source application, please contact our symposium coordinator, Simon Lewis, and you can reach him through the magtug.org website. And while you're on there, don't forget to subscribe to our email list, and you can join the GIS-T discussion group and become involved in what we're doing. A real quick point about the webinar, all of the attendees are on mute, but there is a questions panel at the bottom of your GoToMeeting, and feel free to type your questions there. We will field them and take them at the end of the presentation, and allow everyone to kind of get their initial questions answered. So without further ado, I'm going to turn it over to Rich Grady, Michael Turner, and Kate Hickey from AppGeo and let them talk about the webinar today.
Thanks, Bob. This is Rich Grady. I'm assuming that you can all hear me and that you can see our slides. So I'll just roll into it, and Michael and I are going to tag team on this presentation. And I thought I would tell you a little bit about who we are and what we're doing in transportation. Michael's going to focus in on sort of the technology landscape and then a very specific use case on Texas DOT. And we'll actually give you a demonstration of an application that we've built for them. So I think it's great that you have this webinar series. Knowledge exchange and knowing what's happening out there is really important. So thank you for this opportunity to let us participate in that. Who we are. AppGeo, many of you may know us. We've been around a long time, 24 years. We cover the gamut of geospatial applications, from planning and high-level studies right down to detailed application development and data development. So we've built a lot of solutions across the country. Today we're going to talk mostly about transportation and the work we've done with state DOTs, but we do a lot of work with local government, and that's why Kate's on the call. Kate Hickey is our Director of Local Government Services. And we take pride in our technical expertise. We really lean forward on the technology, and we operate in a number of different platform environments, ESRI, open source, and Google, as well as some of the CADD environments. Now, I'll touch on those briefly in the context of transportation. We're looking at a high-level slide here of some of our customers and services in the transportation space. We've worked at the federal level as well as the state level and in the private sector. We've done planning projects at the national level, Transportation for the Nation. Some of you may be familiar with that acronym. We wrote a strategic plan for that. And recently we completed a study for all roads data integration as part of the HPMS reporting, Highway Performance Monitoring System. So those are a couple of examples of big studies we've done at the national level, and we've worked across a lot of different states on a lot of different applications, street center lines, CAD and GIS interoperability. We've done a lot of work with Bentley MicroStation and Bentley Map and ProjectWise in that context, and bringing that CAD data into the ArcGIS environment. We've done a lot of work with right-of-way information, parcels as they relate to roadways and waterways and railways. Some of the work we've done has been driven by safety and good old mapping. Cartography is a big part of what we've done historically, and still an important part in terms of high-quality output for transportation applications, some state highway maps, for example, and then road conditions. And I think that's my segue to Michael. That's one of the specific applications that really gives us the opportunity to talk about how we bring backroom data into a public-facing web environment, how we take advantage of web infrastructures, and the specific use cases for Texas DOT. And so, Michael, you want to talk about that?
Thanks, Rich, and good morning. Rich mentioned earlier that one of the things we take seriously and have been deeply involved with, certainly on an accelerating basis for the last 6 years, is the reality that there are multiple software platforms out there, and that these platforms have arrived in response to some of the macro trends in technology that are have played out over the past 5 or 6 years. And indeed, the DriveTexas solution is a hybrid architecture involving ESRI technology, Google technology, and a little bit of open source technology. And what I thought might be useful is sharing some of our perspective on how these technology trends have played out, and how you kind of make sense of what's going on, or how we've tried to make sense of what's going on as we look at problem spaces and try and craft the appropriate architectures. And again, the DriveTexas scenario has a couple of the most challenging elements of a web application. I'll say them right at the outset, but we'll return to them. The two things that are really challenging is, one, the data change frequently. Roadway conditions change every minute of every day, and in fact, Texas DOT has a team that is constantly updating those data. And so the web application has to reflect changing data. The second piece is that in a roadway conditions setting, sometimes terrible things happen, whether it's a big snowstorm, like in this part of the country, or even in Texas, or a hurricane or something that requires evacuations and a massive change in roadway conditions. So these sites have to be able to withstand a massive load of potentially tens, if not hundreds of thousands of simultaneous users. And those were the kind of big challenges that drove the architecture we arrived at. And now what I'm doing is sort of backing up and giving you some of the framework our company has used as we've tried to understand the options that are available and how you mix and match the options given the problem that you're facing. There's no doubt that cloud-based technology and mobile technology have changed everything. And really the thing that binds these two together is the fact that the internet is not everywhere yet, but it's making great headway. High bandwidth internet availability in our homes, at work, and increasingly through Wi-Fi almost everywhere you go is becoming a reality. And the mobile is driven by the fact that the devices are here. People have smartphones. The iPhone was introduced in 2007, so we're well into the era where people have, as I've heard some people refer to it, the supercomputer in your pocket. And then the tablet came out, which is, in some ways is, just a bigger a bigger phone, a bigger touch screen to interact with. The networks are improving, and people are voting with their feet or their wallets. And again, to back this observation, when I got my first flip phone, whatever, more than 10 years ago, I never imagined that I'd be watching TV on my phone, or that would have a robust email experience, or that the internet could be so fast or interactive, or that I could navigate my car. Indeed, we've gotten pretty much to where Star Trek predicted we'd be. We're all carrying around tricorders that do pretty much everything Star Trek predicted except the medical part. And so it's a real, and again, people, this trend is going up. People are doing, are voting again with their feet and their pocketbooks. And this slide, which is now a year older from the Pew Research Center, polled people about their use of the internet on mobile technologies. And at that time, 87% of Americans owned a phone, and 45% of them owned a smartphone. I don't know the number, but I certainly would not be surprised if at this point in time, half of Americans own a smartphone. And again, at that time, 31% of people use their phone as their primary mode into the internet. So this is why mobile matters. If you're trying to publish information to people, you have to do it in using the media and the devices that they're using to access information. Cloud infrastructure is less ubiquitous in people's private life, but is increasingly so. Things like Dropbox or Google Drive are basically consumer-facing cloud incarnations. For businesses, especially smaller organizations like ours, infrastructure as a service, the ability to spin up virtual machines on other people's clouds, whether it's Amazon through the Amazon Web Services or Google through their Google Cloud Platform, has been incredibly powerful and liberating. Instead of having to buy and air condition and connect to the internet lots of hardware which breaks, or the air conditioning breaks, you're essentially renting hardware from people whose core competency it is to keep enormous data centers up and running and humming. And indeed, cloud-based infrastructure is also enabling all kinds of businesses, whether GIS places like ArcGIS Online or CardODB, or consumer business solutions such as Salesforce.com, a customer relationship management environment, or it's Christmas card season, so we're using Shutterfly to get pictures out to family and friends. Software as a service is delivered through cloud infrastructure. And so again, these are the kind of macro trends that everyone faces, both in their private life and to some degree at work, especially if you're involved in technology. So why do we like the cloud? It makes economic sense. Renting people's machine instances, as I described earlier, is more cost effective than every 2 or 3 years buying a lot of hardware, installing it, air conditioning it, powering it, and all of that stuff. This is another example where we switched from having our own Microsoft Exchange server, which we had been running, or servers, I should say, which we have been running since 1999, to Google's software as a service, Gmail for business. They call Google Apps for Work. And our system administrator calculated our annual cost between the Microsoft licenses, between our mobile server licenses, good, between the server we ran Exchange on, the server we ran Good on, the server we ran our Barracuda spam filter on. That was costing us $15,000 a year to provide email for about 32 people. we switched over to Google, and that cost is now $3,000 per year. And I think many of us, about a year and a half in, would argue our email is better than ever. It certainly works on our phone a lot better. And to do that, we had a one-time conversion cost of moving our Exchange database over to Google, which cost us $5,000 through one of Google's partners. And, so literally, on my phone, I can actually access, emails I sent people in 1999 or 2000. The whole archive was transferred over. So obviously, there's cost effectiveness to these cloud-based approaches, and the same holds for the geospatial incarnation. So with all kinds of new technology out there, new possibilities both in technology in general and in the geospatial arena, we've developed what we consider to be a best-of-breed outlook. And this best-of-breed outlook, in fact, led us to the DriveTexas architecture. We weren't afraid of mixing or matching. We didn't have a strong a priori proclivity to having everything come from one supplier. We are trying to solve the problem in the best possible way. And if you break it down, best of breed is a dog show term, and the notion is that dogs were bred for particular purposes. This dog herds sheep. This dog pulls fishing nets. This, another dog catches rodents. And by association, you don't want this little rodent-catching dog pulling your fishing nets. You want something that has the best fitness of purpose for the task at hand. And there are other analogies that convey the same thought. One size doesn't fit all, or choosing the right job for the tool. If you have to turn a screw, you get a screwdriver. You don't bash it in with a hammer, even though it's probably physically possible. And in fact, people are very comfortable with a best-of-breed outlook. These are literally my cars. I have 3 kids, so we have a Ford Flex, which is a 4-wheel drive minivan. My wife drives a lot for her work, so we have a fuel-efficient standard drive Mazda. And our kids are driving, so we have the old minivan, which doesn't go so fast and is pretty big and pretty safe. And that's a Toyota. So and the notion is there's no right or wrong choice. It's up to us. We choose the tools we like best, that we think are suited for the problems that we have, and it's our own personal calculus on cost and value. And there's certainly nothing wrong with people who conclude that the best of breed all comes from one manufacturer, and they have all Mercedes or all Fords or whatever they choose, whatever meets their calculus on cost and value. And you can go on and on. You don't have to have all the same appliances in your kitchen. And in fact, in my personal work environment, I have an Android phone, a Mac laptop, and a Windows PC both at work and home. So the point is, again, not that I've made perfect choices. The point is there are choices, and you should be free to choose the things that you think solve your own personal problems in the best way, or your own personal, make you as productive as possible in your own way. And sort of, one last analogy is, especially in geospatial, where we're trying to do so many things, from editing data to making beautiful maps to publishing web maps, is, do we prefer having a Swiss Army knife that does everything okay, or do we seek to have an environment where we do the most important things, certainly, in an excellent way? If given a choice, you're not going to use the Swiss Army knife tweezers when pulling a splinter out of your child's hand. You're going to use the real tweezers. You're not going to carve your best steak with your Swiss Army knife. And, we recognize, I mean, there's no hiding that, ESRI has been a dominant force in our industry and makes, fantastic software. And for a real long time, you could argue was the only choice out there. And, I think that's changed. I think all of us see that there are more alternatives and see that there are more people having success with a variety of platforms. Again, as Rich implied earlier, it hasn't been so clear-cut in the transportation arena, especially in state DOTs, where there's always been a big CAD community doing mapping and design and other kinds of applications alongside the GIS community that often used ESRI. And the point is, at this moment of change, when there are choices, when you're considering potentially a best-of-breed outlook, this is not a decision where it's like, okay, I used to do this, now I'm doing something entirely different. We see very rarely where someone just dumps the old thing and picks a new thing. Rather, legacy systems, ESRI, they have a lot of new and interesting things happening. There's innovation happening with ESRI, and you should be checking those things out. And the ones that you like, go for it. Use them. But also check out the new suppliers, see what other things may fit your use cases, may do things better. And again, we'll get to the DriveTexas and how that calculus played out. And feel free to grow the ones that you like. Not all of a sudden necessarily, but as a branch that comes out of the tree, and through that mechanism, you can handle potentially more than one kind of technology under one roof. And when you have more than one technology under one roof, you start building hybrid systems. And if time allows and there's interest, we can show you a variety of them. I'm going to focus on DriveTexas. But what's pictured here is a local government-focused parcel viewer that we host on behalf of over 70, actually over 100 cities, towns, counties, regional planning agencies, and the territory of the U.S. Virgin Islands. And again, it's a hybrid of some ESRI stuff and some open source stuff through the OpenGeo suite that's supported by Boundless. And it works great. And our customers don't care. They don't ask us about what technology we're using. They may say, we have ESRI data, but really what they want is a good parcel viewing system. And as long as it's a good parcel viewing system, the technology choice is up to us. So enough intro. Some specifics of DriveTexas.org, and again, I encourage you to open it up if you're curious, whatever device you're on, and play with it after this talk or while I'm talking. But it's basically the state's public traveler information system. Some states call it their 511 system. And they chose Google for scalability requirements. Their nightmare scenario is a hurricane in the Gulf of Mexico heading towards Galveston and Houston and potential evacuation orders. And when that kind of stuff happens, and Houston's got about 5 million people, you turn the interstate highways one way out of town, and some real massive road condition changes, and potentially massive loads of hundreds of thousands of people accessing the site simultaneously. As a result, this project had to pass a stress test for what's called 10,000 queries per second. So not only is that 10,000 simultaneous users, but it's 10,000 users hitting a button at the same time and 10,000 simultaneous requests. And long story short, cutting to the chase a bit, this architecture was able to withstand not just 10,000, but during the stress test, they kept turning the dial and got it to 100,000 concurrent users, 100,000 queries per second. And just to give you a sense of what that load is like, the stress testing company used 100 servers just to generate that load. 100 servers simulating 1,000 users each. So it's no small task. One of the other challenges is that the DriveTexas had a mature ESRI environment for managing the road condition changes. Still has. They have 2 or 3 people who edit these data dynamically every day. All these little dots about whether it's an accident or a construction event or a washout or a bridge closure or whatever are dutifully monitored and changed on a daily basis by a team. And so what we need to do is be able to get the data out of ESRI and into Google's cloud on a regular basis, and the period that was chosen was every 10 minutes. And so you'll see when we demo this, the splash screen reflects when the data was last updated, and you'll notice that your system time and the splash screen time are never more than 10 minutes apart. The other important thing is, unlike the previous site, so backing up a second, Google was chosen to replace an existing site that wasn't able to meet some of the requirements, a site that was built using some ESRI architecture, data serving architecture. And what ended up happening is during some smaller weather events, that site was crashing under the load of 300 or 400 users. So TxDOT started shopping for a more scalable solution, which led them to Google. The other weakness in the initial DriveTexas was poor mobile support. And again, it's one of the things that Google offered that was a strong attraction to our team, which is the notion of responsive design. One website that can automatically scale to the device that you're on and looks fine in a browser and also looks fine on a telephone. And this stuff does happen. The weather events that we were talking about do happen. These were some weather events from last month in November. There were some snowstorms, snow and ice storms in northwest Texas, and the DriveTexas site lit up as individual counties sort of declared snow and ice emergencies and were broadcasting that those road conditions existed. So, and those are the precise times when people are more likely to use a traveler information system, when the weather is bad. So we've passed the first tests. I don't know how many people are accessing it, but again, the previous year when this happened, 300 or 400 people would be accessing it simultaneously, and the site was not performing well. So how did we do it? What does a hybrid architecture look like? So again, I've described there's custom ESRI apps that TxDOT has had for a long time that enable them to curate a local ESRI geodatabase of those conditions. And then they publish, an ArcGIS web service out of ArcGIS server, and we built a special widget using Node.js and some open source code that every 10 minutes looks at that web service and it identifies the changes from the previous 10 minutes. And then it pushes those changes into a part of Google's cloud called Google Maps Engine, which manages geospatial data layers and serves them at Google scale. And then the public just uses the site, and this is what's going on in the background. The other thing that's interesting is I mentioned, infrastructure as a service and the ability to spin up your own cloud instances. DriveTexas, this server over here, is actually located in Google Cloud Platform, the corner of their cloud that behaves like Amazon and lets you create your own instances. And it's a little Linux box that runs the Node.js code to create the handshake between ESRI and Google Maps engine, enabling the public this scalable responsive experience. So that's my last slide. What I'd like to do right now is just give you a little bit of a guided tour of DriveTexas. Site's coming up. I'm going to hit refresh now so we can see the splash screen. It's telling me it's 10:29 and it's 10:36. So my data is 7 minutes old, according to the clock on the computer I'm using. And it's really easy to demo this site. The site doesn't do a whole lot. It publishes a couple of important data layers. And so, these are traffic conditions. I can click on any one of them. Come on. This is a problem. Refresh one more time. Are any of you trying it at home? I'm a little concerned. I'm just trying it on my phone now to see if I'm having the same experience. Okay, well that's good. The pop-ups are working on my phone. They're not all drawing.
I think we're seeing the same thing here. It's working on the phone, but not necessarily on the computers.
Yeah, I apologize. I need to notify my team. I'm going to proceed with that, with the demo. I don't know why this is happening. I've not seen this behavior before. What I'm going to do now is one of the things that does seem to be working is when we show both future planned conditions as well as the current condition. And so the notion is we can click on an incident and see what the traffic conditions are at that site. So this is planned traffic. Events. The other thing is as you zoom in, the data are depicted as points when you're zoomed out, but indeed traffic conditions are segment-based. So we also can see the entire segment. So the planned construction on IH-35 will be covering this area. Yeah. Okay. There we go. Again, in the Dallas area, as we zoom in, we can start seeing the traffic conditions. And these two should be clickable, but for some reason this morning they are not. And we will be, there we go.
There's planned construction.
That's kind.
Unshift and refresh the page.
Pardon?
Unshift and hit refresh.
All right, we're a developer in the room here, just taking a peek at the application.
Not a problem. It's always Murphy's Law with live demos, right?
Yeah, it looked to be a caching issue on this particular PC in our conference room. So it's now working for me properly. If it's not working for you, if you hit Shift Refresh, that should replace the cache. And again, now it's working properly. So this is, so again, it's a very simple website that publishes the traveler information and a variety of conditions and reflects both the lines as you zoom in as well as the incidents. The other thing that it publishes is access to Google's live traffic, so you can actually see if there are traffic impacts to some of these road conditions. And it also publishes basic traveler information like the traveler information centers and the rest areas. So again, I can click on a picnic table and see the facilities available here, or a traveler information center and see the information there. And it also links out to TxDOT's traveler information profile of various rest sites. So, in addition to the responsive design, in addition to the base map itself, one of the other things you get is access to Google's friendly search. So, I can type in, one letter and I get Dallas or Denton, Texas, and can zoom there. But I can also do other kinds of search like state capital and get the Texas state capital in downtown Austin. Again, one of the reasons that Google was selected for a system like this is just public familiarity. The public knows how to use Google's mapping tools to a large extent.
I'm told the site was updating right at that minute.
Is that what it was?
Yeah, that's what they said.
So the theory from the development team was that we had, what I was showing you was a incomplete load of the data. It was in the midst of doing its 10-minute shuffle, and so we only got part of the data in the map, and then it's now available. So apologies for that snafu. So with that, I'll go back, and I think that sort of covers the formal part of the presentation. And if there are any questions, we'd be happy to try and answer them.
Well, thanks, Rich. There's a couple here, and I'm going to try to share them with you. If not, I can read them off to you. Or I'm sorry, I'm going to share them with Michael. Can you see that question come across?
Pull down that link.
Oh yeah. don't see the first one is why isn't the data pushed to Google Maps on a minute-by-minute basis for more timely data to end users on the roadways? That's a very good question, and the ideal would be that the data are maintained in real time. The operating reality of how a Google ESRI handshake works at this moment is that there needs to be basically the change detection and for lack of a better term, an extract, transform, and load of the ESRI data into Google's format, as well as the push into Google's cloud. And theoretically, you can do we could do it more frequently. There's talk for version 2 of doing it every 5 minutes. But the bottom line is there is some latency and there is some actual work that this process does that takes a little bit of time, and that's the period that Texas chose.
Okay. There should be another one that maybe came across for you.
Yeah. Why isn't the data pushed to Google Maps on minute-by-minute basis?
No.
I see the one that got. Okay. Yeah.
Click in that window just a bit in the question window.
Oh, I see. I noticed that there are icons on the maps that I think represent incidents or schedule construction information. Does this come from Texas DOT? If so, what is the approximate time between the database entry at TxDOT and the information being available to the public? So that's similar to the last question. It's 10 minutes. As soon as the data is in the SDE database, then it's reflected in the ArcGIS service, and the next refresh will carry it to the public map.
Okay.
Okay, there seems to be one more. Does Google consume and incorporate DriveTexas data in its own map services, Google Maps? I noticed that there are icons on the map that I think represent incidents or schedule construction. The quick answer is no. What we're seeing in the map is TxDOT data, and Google does not attempt to harvest that for their own consumer-based maps. The exception is, and I would have to find it, but for accidents, these aren't sort of typical fender benders. When there's an accident, it tends to be a major accident that's going to be there for hours. Here's one up here. Let's see what it says. It doesn't say what the cause is, but I've seen overturned tanker or something major where there's actually a road closure that persists. And those of you who use Google or use Waze, typically events of this nature will make it to Google through the Waze and crowdsourcing. Put someone waiting in the traffic jam behind that accident. See if we put on traffic. Yep, so if we put on traffic, we can see that at that location there actually is a bit of a backup.
Okay, a couple more came in, Rich and Michael.
Okay, so it looks like they're coming in from the top. Have you thought about incorporating the TxDOT cameras into the interface instead of a link? I noticed there are icons. Yes. Traffic cameras, great question. Yes, there's a version 2 that we're going to be starting on in January, and live integrating the traffic cams is part of that scope. One of the things I didn't tell you about this project was we developed this site in 5 weeks. Due to a variety of reasons, from procurement to the timing of TxDOT's decision to move to Google, we didn't get started until the last week of April and needed to have this available by hurricane season, which starts on June 1st. And as a result, we did the base functionality as quickly as possible. And when we ran into things like the traffic cameras, which had some special needs, they were put on until version 2.
But I would recommend, if you're planning such a system, that you allow more time.
Agreed.
Okay, there's 2 more in there. I don't know if you can see them and come across. One was, what was the total project duration and cost to build/deploy?
What was the second part? The cost?
Yeah.
So the time to deploy was about 6 weeks. So I fibbed a little bit. We were ready on June 1st, but that's when the stress testing began. And again, people were looking at the weather maps, and there were no hurricanes brewing. So they felt comfortable with that. And then we did the stress test, and the deployment was very quick after the stress test was passed. So it's a very short duration project. The cost, the initial version was about rough order of magnitude, was about 75,000 or so of development time, and the state Google charges for access to their maps based on what's called a map load or a consumption-based process. And so this site was modeled to have about 10 million map loads per year, and Texas is paying about $80,000 to $90,000 to Google for those map loads. So, again, big agency, mission-critical application, something that they really can't afford to fail. And so they've invested significantly in it. And version 2 is a 6-figure enhancement that's going to, in addition to the traffic cameras, it's going to make some improvements to the data updating part of it, and then also provide TxDOT its own management tools. So, for example, they'll have a tool where they can change the splash screen, so if there is a hurricane or a major weather event, this won't be so pro forma, and they could push something to this, warning, blizzard in West Texas, take note. Or other things, if there is a hurricane bearing down, they might turn off the construction and just focus on the evacuation route. So the ability for Texas to do some management of this. The other thing that is a real important part of version 2 is managing the evacuation data itself, what they call contraflow. And so tools for having the contraflow depicted more clearly, and also be able to be turned on and adjusted by TxDOT personnel themselves without coding. And then a long list of small incremental enhancements. And along the lines of one of the questions that came up is your device will automatically refresh every 10 minutes. So if you're looking at your device for 10 minutes and don't refresh, if there are new conditions, they'll automatically be pushed to the phone.
And perhaps one of the geographers on the phone could do the calculation of how much of the Mid-Atlantic is covered by Texas. But of course, in the Mid-Atlantic region, we also have the hurricane threat. And recently, the experience with Superstorm Sandy was very telling. And the difference, obviously, is we're more of a granular part of the country in terms of states and number of jurisdictions involved in managing and mitigating such an event. So it's just interesting to me from from a geographic standpoint what our challenge is on the East Coast.
Yeah, Rich raises a good point. During Superstorm Sandy, New York City's hurricane evacuation website went down and was not able to assist during the event. New York now has a Google-powered hurricane evacuation site as well.
Great. I guess
Yep.
one final, I think this is probably the last based on what I'm seeing now, is can you comment on any challenges in implementing the responsive design approach?
You know, honestly, the challenge is, you know, just to sort of illustrate the responsive design for those who may be less familiar, this is how it works, is as I change the size of the screen that it's moving, and at some point it's going to get small enough that the DriveTexas logo disappears. So the elements of the application know about each other, and there's a hierarchy of what appears and doesn't appear at different screen sizes. That's the thrust of it. So the two challenges that I'd say are, one was picking a JavaScript framework for doing the responsiveness, and we chose Twitter Bootstrap, which is out there, open source, widely available, and does a good job. The Google Maps API is inherently responsive itself, and the other part of responsive is it handles touch gestures. You know, so we don't have to program what happens if people drag with 2 fingers or 3 fingers or whatever. That's all in one of those JavaScript frameworks. So we did our homework and chose what we thought is a strong one that had the capabilities we need, but also is backed by a big company and will be around for a while. The other thing is keeping your user interface simple. It doesn't matter how responsive your design is. If you have 26 widgets, they're just never going to fit on a small screen. And so working with TxDOT to keep this as bare bones as possible. And in fact, you know, those of you who are trying it on your phone know that the hide menu button is very important in the phone context. And so just, you know, we had a lot of pushback and forth with the customer about how to keep this as compact as possible, like, you know, having the current and future events toggle through a tab, etc. Having the ability to turn on and off conditions, etc. And keeping the user interface as simple as possible. When the interface is Spartan, there's less stuff to move around and position on a variety of devices. And again, when more and more people are designing for a tablet, you know, for sort of a 6-inch by 8-inch screen, and that's the base. And those things may run on your phone, but they're not really usable because the menus may overlap in the responsive design. But when the end result is your phone itself and the tiniest screen, then your user interface has to just be simple, because some stuff won't fit.
Okay. And actually, one more came in as you're talking. Are the roadway links defined by Texas DOT roadway data, and how do they correlate with Google Maps?
I missed the first part of the question.
Are the roadway links defined by Texas DOT roadway data?
Yes. Really good question. The answer is no. When you're seeing this orange arc, that is not Google's geometry. That is TxDOT's geometry, and you can actually see it. It looks like it was pulled out of their linear referencing system because it doesn't go node to node. And the reality, though, is that Google's base map is excellent, and so as long as the DOT's data are good as well, there have not been problems with overlay. And I actually can't do it here, but I'm going to just, because we intentionally have a scale trap so you can't zoom into the bottom here, because road conditions are designed to be sort of looked at synoptically, and we don't want users zooming too tight in so that they can't see anything anymore. But Google's base map, if I'm just going to go to regular Google Maps.
Well, you're looking for that, Michael. Bob, could you reiterate the question? I just want to make sure we caught how it was phrased.
Yes, so it was, are the roadway links defined by Texas DOT roadway data? And how do they correlate with Google Maps?
So I think the answer is yes, right?
They're not linked, but they're designed to overlay.
I think they were just talking about links as in, you know, hot dog segment, maybe. I mean,
yeah,
I think you've answered the question, but
yeah,
I just want to make sure the person who asked it, you know, that we conveyed the meaning that they were looking for.
Yeah, what I was going to show is Texas, Google's data is derived from aerial photography, and they have actually very good nationwide 6-inch aerial photography. If I zoom down onto the Texas state capitol, you can see the quality of the imagery Google's using to place their roads. It's also informed by their street view fleet. They have a fleet of cars driving the country continuously with high-precision GPS that are positioning the roads. And so basically, the Google base map itself is as good as most DOT data, and so the two work well together, but they are not linked. In DriveTexas, this is a Texas road segment, not a Google road segment that's being colored.
Good. Yeah, that did answer the question. That covered it.
The other thing to notice just about, about Google is in many metropolitan areas, including Austin, they now have really cool 3D models of the cities, and you can interact. There's a little tilt widget in Google Maps now that allows you to work in this sort of oblique 3D mode. And definitely, if you live in one of the major metropolitan areas, it's worth checking out. And again, that's one of the reasons TxDOT and others are attracted to Google. Is Google isn't just harvesting public data. They do some of that, but they're investing in their own data. They're flying their own planes. They're driving their own cars. And there's a big piece in Wired magazine in the most recent edition about how Google curates its own databases. And so in addition to the responsive design and their powerful cloud and massive scale, you're investing in having access to their content. Much of which is free when you use Google Maps, but if you want to brand it yourself or put it behind a login, that's when they require you to buy a license.
Okay, great. Thank you very much. I think you've addressed all the questions. So, and it's a little after 11, so I think it's good. I want to make sure we all thank Mike, Rich, and Kate. Thank you for taking the time out of your schedule to do this. We certainly appreciate it.
You're very welcome.
Just a reminder before we end the call, just for the audience, to mark your calendars for the webinar series I discussed in the beginning. Again, the one in February will be on GIS applications that help snow removal. In April, we'll talk about influencing commercial digital road mapping with our own data. In June, we'll be showcasing advances in GIS education for transportation professionals. Then, of course, our symposium, which is at Villanova on March 5th, 2015 on open source and open data. And again, if you have interest, contact Simon Lewis, and he can be reached through our magtug.org website. So with that, thank you, everyone, and enjoy the rest of your day.
Thank you.
Thank
you. Have a good day.
Yep, bye-bye.
Bye now.